Welcome to Chemistry 1711. This introductory chapter covers very basic concepts that will be seen throughout the course. Chemistry is the study of matter. Matter can either be a pure substance with a precise chemical formula or a mixture, such as a salt solution. Pure substances can either be an element, which cannot be broken down into simpler substances, or a compound, which is a precise combination of two or more elements. Substances have physical and chemical properties. Physical properties can be measured without destroying the substance, such as measuring a melting point. Chemical properties can only be measured by reacting the substance and losing it via a chemical reaction, such as a compound decomposing when exposed to water. Properties can also be either extensive or intensive. If the property does not depend on the amount of substance you have, then it is intensive. Examples of intensive properties are density, melting point, boiling point, and color. In this course, we will typically be working with SI units. However, rather than using kilograms, masses will typically be given in grams. Similarly, for volumes, rather than using cubic meters, we will use liters. We do this as the masses and volumes used in a laboratory setting are on the orders of grams and liters, and far smaller than kilograms and cubic meters. For temperature, the SI system will use Kelvin. On the Kelvin scale, the lowest temperature physically possible, called absolute zero, is equal to 0. On the Celsius scale, absolute zero is negative 273.15 degrees. One can convert a temperature in Celsius to a temperature in Kelvin by adding 273.15. Remember, all the formulas you will see this year with the T symbol must use Kelvin. However, for a temperature difference, a delta T, both Kelvin and Celsius yield the same result, as they share the same unit spacing. Finally, in this course, we will often use scientific notation, as some numbers are either far too big or far too small to express in regular notation. Also, significant digits will be an important concept. Meaningless digits after the last truly significant digit in a final answer are not harmless. They convey a false sense of certainty that can lead to important errors when precision is required. Significant digits are all the digits to the right of the first non-zero digit. When doing calculations, one must respect the rules for significant digits. In additions and subtractions, the final answer can only be expressed to the decimal position of the least precise decimal position in the numbers being added and subtracted. For multiplications and divisions, the final answer can only have as many significant digits as the number being multiplied or divided possessing the smallest number of significant digits. For intermediate calculations, it is acceptable and even encouraged to carry insignificant digits throughout the calculation, so as to avoid round-off error. But for the final answer, respect the rules for significant digits.